Well, hi, good morning, and thank you for joining me in my shop here on October 30th. Another dark, gray, rainy day here. The high today is 4 degrees. I've had to explain this to my cats. They're not listening. They don't want to hear it. They want the sunshine back. I want the sunshine back too, especially when it comes to this radio, and I think I may have found some sunshine finally, just before I turned the cameras on this morning. I thought I might just quietly study the schematic and the layout diagram on the radio and ponder this capacitor, which is really bothering me a lot because I cannot imagine why you would connect a capacitor to this position. But now I can. I can imagine why, but it's not a good reason. It's a mistake. But let's take a look at what I got. I'm going to show it to you, what I figured out. It's not a 100% story yet. There's still more to be judged about this, while we're still looking at the radio, the layout diagram shows a wire going from this terminal to the chassis, grounding this terminal, which is weird, also weird. The schematic, as I show you, when I show you, doesn't show this last leg of the resistor. It ends here with just these terminals. Doesn't have as many terminals, and there's no capacitor. But let's just look at that a little bit. We'll look at the two diagrams, and notice also this capacitor is tied to this binding post here, kind of in the middle of this component plate. There's a resistor here and a resistor here, and this is and we're going to look at these two resistors first on the schematic to get that's our landmark. The two resistors. Now, what's happened to my mouse here? Let me start having trouble again today. I've been having so much trouble with the computer. No, here we go. Okay, starting with this diagram, here are the two resistors. One is here like this, and the other is on a funny angle over this way. In my radio, see, my mouse isn't moving now. Okay, I'll sort this out. There is a capacitor connected from this center post all the way to here. And this does not exist. Did it exist at one time? So I looked at this terminal. Hard to say if it's been desoldered and there was an extra wire on it. There is a wire on it now going somewhere else. Oh, incidentally, not shown here. Not shown here. So what that's doing, I don't know, but there's a wire heading somewhere from here, heading up into this area. We'll have to look at that more closely. Okay, and there's a capacitor going right from here right to here. Now on the diagram it shows 29 and 29. There should be a capacitor right here, but there is not. Instead, the capacitor runs straight over to here. Why would somebody do that? Why would they do that? Let's look at the schematic now. The schematic. So here we are. We're missing the 500 ohm resistor here. The two resistors that one on the funny angle are these two here, 60,000 and 200,000. And the capacitor running from the tie point in between, this is the capacitor in question. But it shows it going over to a spot where there's a 500 ohm resistor. The same value that's missing down here. So could it be, in a fit of massive confusion, not unlike what I'm in, a predecessor made this connection. Instead of to here, he saw the 500, and he saw the 500, and reasoned out that the capacitor should go here, and this should be removed. Or is there even more to the story that I don't know? Probably there's even more to the story here that I don't know. There could even be parts of this story that I am not going to figure out by looking at these diagrams, because there could be another diagram, different again, with stuff on it that I'm not going to see. So what's this guy doing? So this guy's actual job, a 0.25. I think they're trying to force the output signal to be entirely across this resistor. Like this is basically a signal ground point here, except for 500 ohms. When you're facing a 200,000 ohm resistor, 500 is a zero, I would say. So the objective here is to make this into a signal ground here, and then all the signals across this resistor, and therefore right across the grid to cathode circuit. So to connect now, what's the relationship between this and this resistor down here? There's no relationship at all down here. There's no relationship whatsoever, I believe. I always have to throw in the caveat at the end there. So hooking up this capacitor to this position, would that introduce a hum like we hear? Oh yeah, it could. I think it could. I think it could, because you're connecting through a capacitor the grid of the output tube to, well, this is supposed to be a well-filtered DC supply, when you shouldn't really hear any hum here. But considering the state of affairs with this radio, maybe there is a hum in here still. When you're just conveying the hum right to the tube where it's amplified and we can hear it. Wouldn't take much hum. The other thing it would do, gee, I don't know what it would do about this voltage divider here. Most of the voltage is going to fall on this resistor anyway. Most of the signal is going to show up here no matter what. Reduce the output a bit. I don't know what else to think here. What's really going on in my head is, should I cut this capacitor as it is in the radio, run the radio, see what happens. If it's in the wrong spot, cutting it, I'm not really cutting it from here, I'm cutting it from who knows where. And where is this 500? Can we find this 500 resistor as a discrete resistor on the cathode? We probably can. Why don't we try that? We'll look for this resistor, and then we'll verify that this capacitor is not there. Maybe there's another capacitor hooked up here somehow. And what about this big one? This is also trying to fix a signal ground right at the bottom of this resistor. I believe. So we should find a capacitor, a big one, hooked at the top of this resistor. Let's go looking for that, because they can't hide this. Let's go see what we can find here. What can we find? Well, you know what? Let's go back. Well, it's not. I was going to say, let's go back and look at the layout diagram for where the 0.1 is. This is probably the 0.1 right here. So I want to look at the output tube. One, two, 3 and 4. Pins 3 and 4 on a number 41 output tube. Pins 3 and 4. How's that going to help? What am I doing exactly? What are you doing, man? Pins 3 and 4 are screen and grid. 4 is a grid. 4 is a grid. Let me just, on my own here, put the schematic back up. Yeah, so we should be finding, well actually, let me change this I was changing the, I thought I was changing the grid blocking capacitor for the output tube, but this is actually connected, yeah, connected to the output tube here. Yeah. And right on the grid, pin number 4. 1, 2, 3, 4. So 3 is a screen. Right? 41, 3, screen. Five is the cathode. So off the cathode, we should find this 500 ohm resistor off of pin number 5, just after the grid. So here's pin number 5. Number 5. Okay, there's a wire coming off of it. Oh my gosh, there's, okay, guess what? Guess what? So there is a wire coming off of it. It goes right to here. And it goes right to the cathode. Okay, try not to close the book this time, Jim. Cathode is pin number 5, grid is 4, screen is 3, plate is 2. Plate, a nice red wire on it, screen, grid, and cathode. Cathode has a wire coming down to here. There's the 500. Doesn't make sense, does it? If this is chassis ground, then visually we could take this resistor, turn around, stick it up here so that this looks like it's on the ground. Because part of what's happening to me is I'm having trouble visually manipulating the visual information I'm getting to the way it should be. This is the bottom of the resistor, so to speak. This is going up the other side, if you can think of it that way. Or pictured as a separate resistor connected to the ground point. But this isn't grounded anymore because this capacitor's here because he tried to connect it to the 500. He tried to, so he had the same visual problem probably that I'm having. And he just couldn't accept that this would be grounded. And then the capacitor would connect here. But that would solve everything. Wouldn't that fix everything? Would that fix, well, everything being the hum. And being the fact that none of this stuff is matching anything. So, oh my gosh, you know what I just saw? Oh my gosh, I can't believe it. How long have I been working on this radio? And so my particular angle is visual angle is very similar to your visual angle. And I look at this terminal over and over and over. What I haven't seen is that wire to ground is still there. It's still here. So this capacitor should really be connected here. Right? Okay, I'm going to stop for a bit, drink some coffee, then I'm going to review all these conclusions. It looks like this capacitor has been put in the wrong spot. And simply moving it down to here is going to solve the hum and release all the psychic tension that I am suffering right now. Catharsis lies ahead. Yeah. But actually, oh, coffee time. Okay, well, I have been staring at the diagram, and things are starting to make a little more sense. For instance, this capacitor, which is a 0.05, on the schematic, and on the schematic. It shows a 0.25 running from here, to this terminal. Now, where's this terminal going? So if you follow this wire, and it's really hard to do, it eventually goes over to the grid. So if we put the capacitor back in here the way it's shown, and put a 0.25 there, and get rid of this, we're done. That's what it looks like. Wrong size capacitor in the wrong position. Doing what's shown on the diagrams puts the capacitor in the right position, hooks it back up properly, solves this mystery of the 500 ohms here. There's no mystery now, and this is a ground point, and this guy should never have been connected to it. That's what I think. Okay, before I take action, I'm just going to think about this a little more. I don't want to, I don't want to jump out of the frying pan into the fire. That's what I'm trying to avoid now. Okay, I think the best way forward for me is to cut this capacitor off here. Test it with this still connected, but I'll do a capacitance test on it. Reconnect this capacitor on a test basis to the terminal I believe it's supposed to be connected to. This terminal and this terminal are the same thing. They're connected via wires. So I could have the capacitor go here or go there. Well, obviously here is easy. So I'll move this down here. By the way, one of the problems I've had in dealing with this is when I saw this capacitor connected here, and I thought it was the only connection. So if you remove this, what was connected there? And again, I didn't see the wire, which is just positioned perfectly to be very hard to notice back here. Had I seen that wire, I wouldn't have worried about it, but I'm thinking, well, disconnect this capacitor, leave a terminal open. That can't be right either. Well, yes, it can be right. The terminal is not actually open. So I think it's the best way forward. Disconnect, test, reconnect, run the radio, see if that hum disappeared. Okay, that's the plan. I want to preserve this wire a little bit here. Let's just try desoldering it if we can. Yeah, it's things become really complicated when you have a number of mistaken ideas, or things you don't know. You don't know, that kind of stuff. And that's why I've learned to become extremely hesitant in these situations where stuff's not adding up. Not to just go ahead anyway, because the next thing you do, you make problems on top of the problems. You start burying the problem deeper under dumb things you've done. There's not much solder here. Stay there. And of course, this is sort of a general truth. Not just in radio repair, but make yourself dig your hole deeper, I guess would be the phrase that we tend to use for that. Okay, let's see if we can get this ray off here. Maybe it's just tacked on. Yeah, just tacked on. More or less. Now this is the wrong size capacitor. It's supposed to be a 0.25, and this is only a 0.05. And oh, I was going to test it. That's right. Test it. Oops. .05. And that's just what it says, 0.05. Fantastic. That suggests this capacitor is actually in pretty good shape. So we know what we got here. Could it be as simple as that? Yeah. Yes, it could be. Now, the characteristic of the hum is I turn the power on, a second or so goes by, the hum comes in and just stays the way it is all the time. Nothing changes it after that. So that's what we're looking for. I'm going to flip this on. We're looking for the hum to not come in right away. And what else can happen? Well, this could be a terrible mistake. Let's see. Well, nothing's going to happen unless you plug it in. I got to plug it in. Okay, here we go. This time for real. No hum. There's the hum. The hum is still there. Is it worse? It's going away. Strong at the start, but it's kind of gone away. But I still hear it, and this is not in a cabinet. Well, radio's working. And this is 1/5 the size it should be, according to the schematic. This should be a 0.25. I have no antenna connected. Now you gotta wonder, okay, was that the right thing to do? I'm sure it was. Really hasn't made much difference in the radio. I go to replace this with a 0.25, I can put it in this position where it's supposed to be. And do away with this connection entirely. I'm going to try that. I'm going to examine the documentation once again, reconvince myself that there should be a 0.25 capacitor between here and this point, and that is exactly the same as this capacitor, just 5 times bigger. And we'll see if that doesn't have an effect on the radio. You must know that saying, better late than never. So this is the bottom corner of the schematic, and down here is a diagram I had not noticed until just now, showing the resistor board connections, and it shows all the resistors, how they're connected and all that kind of stuff. It shows the components. You know, here's the 4 microfarads here. Yeah, that's one that I replaced. I actually replaced this one. Yeah. And you know, they're all labeled and they're all you're told what they are, except for this one. This is the key one. This is 29, part number 29, and he didn't put the part number and he didn't put the value on it. Is this part of why things went wrong, based on my theory that an error was made, because this diagram is missing some information here? Or did the last guy never see this diagram too? Okay, just wanted to show you that, you know, better late than never. Okay, let's give the radio another test. I've got the permanent capacitor in there. This is the correct size now. Is that going to eliminate the hum? I kind of doubt it. The hum did not seem to change after making this change. So I think I'm in the wrong ballpark here. Ready? Everybody ready? Are we ready? Plugged in? Yes, we're ready. Here we go. I hear the hum already. And my furnace is running now in the house, and that makes the hum a little harder to distinguish, but I can hear it quite clearly. Just want to make sure the radio is operating. It has no antenna. That's me as the antenna. Okay. Well, okay, it survived that. Now, the hum is very, very low now. Okay, I'd say I don't hear a hum now. I'd say it's hum free. Or the hum has come way down. Yeah, I don't think there's any doubt of that. Maybe there was an initial hum during the startup from some other thing happening. But I think the hum has been eliminated. Yeah, that's great. Okay. A big breakthrough. Now, everything should be just honky-dory from here on in. And what is left? Oh, a bunch more capacitors need to be changed out in this yet. But I think I've solved this thing here that's been driving me nuts the whole time I've been working on this radio. I think I got it finally. Okay, that's good. I think I'm going to leave it right here for today. And, quit while you're ahead. You know that phrase. And tomorrow we'll get back to just kind of replacing capacitors and moving along. Because there's a big one here, there's a great big honker up here. Lots to do yet. Thanks a lot for watching, and I hope you're getting a kick out of this. And I'll see you on the next video.